Hello and welcome to another exciting math video. This one is going to cover a review. We are going to review 2-1 to 2-3. We've got a little test coming up, and these questions on the review will be similar to the test. So let's dive right in. Let's read the directions, sketch the graph of the quadratic function, compare it to the graph of x squared. Well, I'm going to switch to red ink, and I'll do x squared here. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared would be 9, and that would be just off this graph. Negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. So here is our basic graph, our parent graph. And we got our new function here, h of x is x squared plus 2. So let's go through our shifts. Is there a horizontal shift at all? No, there's no horizontal shift. Stretch or shrink. I don't see any coefficient out here and there, so no stretches or shrinks. Any reflections? No, we didn't reflect it over either axis. So it looks like we just got a vertical shift up 2. There's our x squared. The plus 2 outside of the variable means that's a vertical shift. So we're just going to bump all the points up 2 units. So our vertex won't be at the origin. It'll be at 0, 2. And then we'll go over 1 and up 1 to 1, 3. And if we go over 1 more, we'll go up 3 to get our next point. So negative 1, 3, negative 2, 6. Blue is our shifted parabola. We just shifted it up a couple of units. Ooh, now here one, we got a negative out front. We do have a 2 in front of our x squared. So let's see. Is there a horizontal shift? Not on this one. Is there a stretch? Yes, we do have a stretch. We've got a 2 in front of there. So that's going to be our y coordinates, y times 2. Our y coordinates are going to double. Reflect. We've got the negative outside here. So that is a reflection over the x-axis. Over x, that's supposed to be the letter E, over x. And finally, vertical shift. This does not have one. So let me see, can I make this a little bigger? Yeah. So x squared and negative 2x squared. Good old x squared. Oh, and it's going to do that again. 0 squared, 1 squared, 2 squared. So here, I'll just do these points to keep this kind of simple. So our stretch, remember we're going to times our y coordinates by 2. So that's going to stretch them up. Let me go to blue ink here. So this y coordinate was at 1, 1, so that's going to be 1, 2. We had this point, 2, 4. Well, we're going to double that y coordinate. Now it's 2, 8. And these points, because of the symmetry, are going to be reflected over to the other side of the y-axis. So we're going to have this over here and up here. So there is our stretch. But remember now we also have to reflect it. And that was over the x-axis. Over x. So this parabola that's up above in quadrants 1 and 2 is going to get flipped down. So what we can do is just make our y coordinates negative. So this point here was 2, 4. When we reflect it, it will be or no, that was, excuse me, 1, 2. I can't read my own graph. We had this point 1, 2, but now we're going to reflect over the x-axis, so our y coordinates go negative. So now we're over 1, down 2. This point over here was negative 1, 2. Well, now it's going to be negative 1, negative 2. The vertex will stay the same. And what is another point we had up here? Oh, 2, 8. So we're going to go 2, negative 8. All our y values have changed sign. So now the parabola opens down. There we go. That's a nice graph. Here, write the quadratic in standard form, quadratic function in standard form. Identify the vertex, the axis of symmetry, and the x-intercepts. So first, let's get her into standard form. There is no constant on there, so this will make it a little easier. If we set up our binomial, we'll bring down the x and the minus. Here we're going to cut that in half. That's going to be x minus 1 quantity squared. But if we FOILed that out, we would have last times last would be a plus 1. So we add a plus 1 to get this factorization to work, and to keep it balanced, we're going to minus a 1. So there's our standard form. Y equals x minus 1 quantity squared minus 1. Now the vertex we just pluck right out of there. We'll take this and sort of change that sign. We got a minus 1 in there, so this will be a plus 1. And we just bring the constant down with the same sign, negative 1. There's our vertex. Axis of symmetry, well, that's just x equals this number. That's our vertex, and the axis of symmetry goes right through the vertex, so it's that line x equals 1. And now for the x-intercept. We set the original equal to 0, or if it'd be simpler, we could set this one here equal to 0. In a more complicated problem, that's how we'd proceed. But in this case, we can go back to our original equation, x squared minus 2x. There's our original function. Set it equal to 0. Okay, factor out an x. That'll leave an x minus 2 in the parenthesis. Now, if we set this term equal to 0, we get an x-intercept of 0, 0. And if we set x minus 2 equal to 0, we get x equals 2. And if we want to write that as a point, it will be 2, 0. Okay. Number 4, same thing, but now it's a little more complicated. Got to be a little careful there. We got our x squared is at the end and it's negative, so let me rewrite this in proper form. X squared plus 4x. I'm going to leave a little gap and put my plus 3 there. Now we do have this negative here, so let's sort of factor that out of these first two terms. So that's negative quantity x squared minus 4x, and I'll leave some space in there, and we got a plus 3. Okay, let's find our binomial. Bring down the x, bring down the minus, bring down half of that number would be 2. And when we bounce back up, we're going to square it. Negative 2 times negative 2 is plus 4. Now, if you see a plus 4 here and you think minus 4, well, we got to back up and take account for this negative out front. When we distribute the negative, what we've actually done here is subtract 4. So if we have subtracted 4, we need to add 4 to balance it. And then if we add the 3 and the 4 together, we get a plus 7. I just noticed I'm missing my squared there. And we got a negative out front. And I think that's going to be standard form. So let's write it as y equals negative quantity x minus 2, that quantity squared, plus 7. Okay, the vertex, let's just pluck it out of there, change the sign on the 2, leave the 7 alone. So that's 2, 7 is our vertex. Axis of symmetry is just x equals 2, the same x value from our vertex. Now here, let's get the x-intercepts, and here we'll use this form that we completed the square on. And can I do this? Well, I'll fix that. There we go. So here is our we forced it into standard form. Let's set that equal to 0 and solve this for our x-intercepts. The first thing I'm going to do is move the 7 over. So here it's a plus 7. On the other side, it's going to be a minus 7 equals negative 7. And now we can divide and get rid of the negative. If we divide both sides by a negative 1, these will both change to plus. And now we can take the square root of the left side and get the x minus 2 out of there. And when we root the other side, do not forget the plus minus. Positive and negative root of 7. Last step is add the 2. So we get x equals 2 plus and minus root of 7. Now we're going to list them out both. And if you're doing this on WebAssign, it asks for the smallest x-intercept first. And we are going to write them as points. So our smaller of the x's are going to be 2 minus the root of 7, comma, 0, because it is a x-intercept. We should have a y value of 0 if we're crossing the x-axis. The larger of the two will be the 2 plus the root of 7, comma, 0. Number 5, directions are simple. Describe the left and right hand behavior. So what is the graph doing to the left? What is the graph doing as we go to the right? And this is all driven by the leading term. So here is a negative 2x squared. The 2 is not really that important. It's negative and it's x squared. You know, just a plain old x squared, if it's a positive x squared, it opens up. Since it's negative, it will be opening down. So to the left, we fall, and to the right, we fall. It's going downhill both ways. Even exponent is parabolic in shape, and the negative means we're opening down. Now, careful on 6, they tried to trick us. X cubed, x to the 4th, here's the real leading term. X to the 5th is the most powerful. It's going to drive the behavior of this function, especially the end behavior. It is an odd exponent and it's a positive. So remember when we did the graphs of like x cubed, we would go up in the first quadrant because positive 1 cubed is positive 1. But if we cube negative 1, we get a negative 1. So the graph would look like this. Again, that's x cubed, but it's also the same for x to the 5th and x to any odd power. So to the left, we're going to fall. And to the right, we are going to rise. Fun stuff. Number 7, sketch the graph of the function by finding the end behavior and the real zeros and their multiplicity. It does say to plot some extra points. Don't always have to do that, though. So first, end behavior. It's a negative x to the 4th. So if it's even exponent, it'll either both open up or both open down. The negative here means we open down. So I'm just going to write it like this, down and down. And what I can even do, I'm going to switch to red ink so it sort of pops out. I'm going to draw on my graph here. I know in the long run, we're going to be going down in each direction there. All right, so A, we figured it out. B, the real zeros. So we set our function equal to 0. 3x squared minus x to the 4th equals 0. Factor out an x squared. And that will leave us a 3 minus x squared. So this one, if we set x squared equal to 0, we're going to get x equals 0. So we either, we'll talk about that in a minute. Well, we'll talk about it right now. This, the exponent is even. It's x to the 2nd power. So on this one, we're going to bounce. We're not going to cross. So we're going to touch and turn. Touch and turn. We're not going to cross the x-axis at 0. But inside the parenthesis, let me switch to blue ink. I'll move over here. If we set 3 minus x squared equal to 0, add the x squared, and you get x squared equals 3. Now, it's not a perfect square, but we can square root it, and we'll get x equals plus or minus square root 3. Square root 3, I think, is about 1.4 or something like that. It's definitely between 1 and 2. And these are each first power. So at each of the positive and negative root 3, positive root 3 and negative root 3, we are going to cross the x-axis. So again, if I can't make the graph any bigger because it's tied into other stuff. So let's see. I'll go back to red ink. At the origin, we're not going to cross. We're going to bounce. So we're going to bounce when we hit that red dot. And the positive and negative root 3. Again, that's in between 1 and 2. So I'm going to use my blue ink. I'm just going to put an x in between 1 and 2 and negative 1 and 2. Now it does say plot some extra points. I always check for the y-intercept. If you plug zeros in for all the x's, out will pop the y-intercept. But in this case, it's also going to be the origin. So let's see, I'm going to start over here in black ink on the left. I'm down here at the downward arrow. I know in the long run the graph goes down, but let's see, as I start working my way up, I know I'm going to cross at negative root of 3. Okay, so I'm up here in the second quadrant. My next thing is I got to hit the origin, and remember we're going to bounce. So I'm going to hit the origin and bounce off it and come back up. Now if I look what I got to accomplish, I'm going to cross at the blue x here on the positive root of 3, and that means I'll be able to come down here and meet up with my arrow for my end behavior. So here we're back up in the first quadrant. We cross at root 3, and we're headed downhill. So, your end behavior should match up with the rest of the function. If I was coming along here and I had to cross the x-axis one more time, but my end behavior arrow was up here, I'd be in trouble because I would cross the x-axis, but I don't have another spot to cross it and get back up to my end behavior arrow. So in this case, it worked out nice. We cross here at root 3 and meet up with that arrow going down just like we're supposed to. So our graph kind of looks like an M there around the circle, or around the origin, excuse me. Number 8. Ooh, this one looks like fun. All right. So let's see. We've got a 5x factor. And then here, x squared minus 2x minus 1. Well, that's just x minus 1 quantity squared. And I got so excited to work on that part, I did not do the end behavior yet. Let me make this graph a little bigger. Now, the end behavior, we sort of got to think about it. If we distribute the 5x to the x squared, that's going to give us 5x cubed. Now, that's going to drive the function. It's positive and it's x cubed, so I know I'm going to go up to the right and down to the left, like any odd exponented function. The zeros. Here, if I set 5x equal to 0, I get x equals 0, and it's first power. So we are going to cross at the origin. So here we're going to cross. Let me do a little x. If we're going to cross, let me put a little x on there. Now the other term, x minus 1 quantity squared, set the x minus 1 equal to 0, you get x is 1. So at 1 we're going to hit the x-axis, but because it's even multiplicity, quantity squared, we're actually going to cross. So here at the red dot we're going to, we're going to bounce, excuse me. We're going to touch and turn. So a red dot, we're going to bounce off the dot and we cross on the x. So let's see, we're down here going down to the left and I start working my way up. I know I cross at the origin on the blue x and I'm coming down this way and I hit at 1 and I bounce off it, and that's good because I got to meet up with this arrow that's for my right hand end behavior. And there's our graph, or at least a sketch one. It might not be perfect, but it's pretty good. It gets the job done. Oh my, look at this one. I see 4 terms, x cubed at the lead. Well, end behavior, x cubed. We know we're going to go up to the right and down to the left because of the odd exponent. And now here, if I factor if I group the first two, I can pull out an x squared, leaving an x plus 3. In the next group, if I factor out a negative 4, that leaves me x plus 3. Now I'm going to have an x plus 3 factor, multiplicity 1, and then I'm going to have x squared minus 4. Let's factor that x squared minus 4 into an x minus 2 and an x plus 2. Okay, so we've got 3 x-intercepts. X equals negative 3, x equals 2, and x equals negative 2. So and all of these are first power, so at each of these we will cross the x-axis. We're going to cross at 3, we're going to cross at 2, and whoa, we're going to cross at 2, and we're going to cross at negative 2. Now, one other point that's easy to get, let's find the y-intercept, plug in zeros for all the x's. At the end, out pops a negative 12. So to actually graph that, we'd have to go well off the graph down here. So let's see, we're down here on the left, or the down arrow on the left here, and I'm working my way up, and I know all these x-intercepts I cross. So I know I'm going to cross here. Oops, hold the phone back up. I put an x-intercept in the wrong spot. I should have had one at negative 3. Negative 3, negative 2, and positive 2. Okay, there we go. Because the other way I wasn't going to get to my y-intercept. So here we are again down to the left, and let's start working our way back up. Okay, we're going to cross here at negative 3. That works, and we're up here for a while, and then we cross again at negative 2, and I know my y-intercept is way down at negative 12, down here somewhere, and as I'm coming back up, I got to meet up with this arrow taking me up to the right, and that's okay because I got one more x-intercept to let me cross, and now we're heading up and away. So there's our graph. Again, it's just a sketch. It's not perfect, but the important stuff is there. The end behavior and the intercepts. Long division. So we're going to divide x squared minus 5x minus 1 into, we got a 5x cubed. We got, oop, that's a pretty terrible exponent. That's even worse, cubed. Minus 21x squared minus 25x minus 4. Okay. Let's see, up on top, we want to eliminate 5x cubed. We've got an x squared, so we're going to multiply by 5x. And remember, we're going to distribute that 5x to all three of these terms. So that's going to be a 5x cubed minus 25x squared minus 5x. Now here, I'm going to distribute a negative and then add. So all these signs switch, and now when I add, I get 0. Here will be a 4x squared. 5x minus 25 is minus 20x's, and bring down that last term there, minus 4. So let's see. I want to get rid of 4x squared, and I got an x squared, so I'm going to multiply everything by a 4. Let's distribute that 4x squared. 4 times negative 5 is negative 20x. Oh, this looks perfect. 4 times negative 1 is minus 4. If I distribute a negative and add the columns, 0, 0, 0. So we have no remainder. That worked out beautifully. So again, what we did here is we figured out the factors here. If I multiplied this, our answer, by our original divisor, if I FOILed that all out and collected like terms, I should get back to where we started. Okay, and saved an easy one for end, synthetic division. Now, I already noticed we're missing some values or some exponents. So that is 1x to the fourth minus 0x cubed minus 2x squared plus 9x plus 0. And we are going to divide. Our factor is x plus 3, so we're going to put a minus 3 there. And we bring down the first term 1, and we multiply and get negative 3, and we add those and get negative 3. Multiply to get a positive 9, add up and get a 7. Multiply there and get what's that? A negative 21. 9 minus 21 is negative 12. Negative 3 times negative 12 is positive 36. Oop, I put that in the wrong spot. Oh yeah, positive 36. We add that to the 0 and we get 36. Now, we're not done. We divided, but we still got to put our x's back in. We started with x to the fourth. We divided by x to the first. So that means down here our first term will be x to the third. So that 1 is a 1x to the third minus a 3, x to 1 power lower, plus 7, x to 1 power lower, minus 12 is our constant, plus, remember, our remainder is a numerator over the original divisor, quantity x plus 3. Okay, I hope this was helpful in getting you ready for the test.